About 6 years ago, I sold my apartment. I packed up my things into 2 suitcases, and I moved to New York. And I found myself in a situation where I was in a city that I'd never been to, in a country that I only had visited once, and I was tasked with building a company in an industry that I was completely unfamiliar with. So part of that, as a technical co-founder, was obviously that I needed to build a technology stack from scratch, and I also needed to build this team from scratch at a place that didn't have a network. So that challenge was a little bit daunting right away, until I realized that as a long-time techie and a nerd, I had a whole bag full of solutions looking for problems to solve. And one of those solutions was a language that I had really wanted to do something with for a while, and that was Scala. So I used to be a Java developer. I've been in Java land for about 10 years, and then back in 2009 or so, I discovered Scala. And what appealed to me with Scala was, well, number one, that it was on the JVM, so I could use and leverage all of the things that I learned in Java land for the past decade. But I was also drawn to the language itself. I liked its terseness and its expressiveness. And although I did not have a lot of functional programming experience except from back in college, the functional aspects also appealed to me. So I thought this would be a great way for me personally to have fun building something new with a new piece of technology. But I also saw this as a way of attracting people to come join me in building a team because I didn't really have that many other things going for me in New York as a freshman there. So Tapad started using Scala as the main programming language from day one. Now, being a single curious developer and exploring a new language is all fun and all well. But it's very different to be a single developer, as in different from building a larger team. So today, Tapad has about 50 developers, and of course, you could also see scaling to much larger organizations as well. So this talk will be about some of the things that I think are important when you're trying to take Scala from being an interest of 1 or 2 people in a company into something that actually scales to a larger organization. So before I get into this, how many here are actually actively working with Scala on a day-to-day basis right now? Right, so most of you. And how many are just kind of looking into it and trying to learn? Okay, so a few people as well. Okay, good. So the first thing I think is important when you're trying to scale an organization on Scala is frameworks. And frameworks is something of a little bit of a contentious issue in Scala land. So how many people here feel like frameworks are good? No one. Oh, no, a few people, okay. And who thinks frameworks are bad? One person over here. I'm going to ask you, why are frameworks bad in your opinion? Okay, so the answer is, or the answer you gave here is that you have to fit your solution into the framework that you have. And that's a common gripe with frameworks, especially in the Scala community, is that frameworks are constraining. They don't allow me to do things the way that I want to do. I'm going to say that my position is that having too many degrees of freedom is actually something that hurts developer productivity. So constraints or constraining patterns are actually something that is kind of a virtue, something that is good for developers. And there are a number of reasons for that. I'm not disagreeing with your statement, by the way, but constraints can be different things. And in Scala land, frameworks are kind of connotated with the negative constraints more than about the positive. So constraints, if they're designed well, they will allow developers to focus more on the actual business problems they're trying to solve for rather than the implementation details. It also, if it's done well, will increase the approachability of your code base, makes it easier for people, either if they're moving from one team to another within an organization or if they're coming from the outside. If you have a code base that is constrained within easily understandable patterns, it will make it much easier for those teams to, individuals to get up to speed and be productive sooner. constraints also make it easier to refactor and maintain your code base, because as your patterns evolve, it's much easier to change one pattern than it is to change a large number of patterns. So I think, again, in the traditional Scala perspective on frameworks, about just being a purely bad thing, I think that frameworks are actually really important for developer productivity if they're done right. So a framework is not just this big block of code like the Sprint framework that might impose seemingly unneeded constraints on you as a developer. It's more a combination of and a formalization of patterns and best practices. These best practices, they can either be codified, they can be part of the application or the framework code that you have, or they can be more of a mental model, a general a consensus on how you actually do things. And again, very important in order for teams to stay productive as they scale. So patterns shouldn't be static or rigid. And I've been thinking a little bit about how patterns actually evolve as you pick up a new tool or you work with a new tool. So like a very, very simplified process here. You start in step one, you pick up a new piece of technology, in this case in Scala. And you start, as a curious developer, you start thinking, okay, what are the things this thing can do? What is it that Scala as a language can do? And you explore the capabilities of the language or the tool that you're working with. And then the next step would be, of course, to start looking at, so how can I do this thing that I need to do, this X thing? Whether it's consuming a web service or building an API, how do I do this with this tool? You find one way, and you probably want to look at, okay, are there other ways that I could do this as well? And you enumerate the possibilities that are available to you at the time. And then you choose. You choose what's the best way, in my opinion, or we as a team, in our opinion, what do we think is the most reasonable approach to solve these kinds of problems? So you pick one way of doing it, and then you formalize that into a pattern. And in the beginning, that pattern is formalized probably just in the heads of the people that are involved. Hopefully, then you move on to the next step, which is actually getting work done. But while you're getting work done, you start questioning some of the assumptions you made in step 4. You say, okay, is this really the best way to do it? And you kind of evolve your patterns. You learn new things. You either extend the things that you have, or you choose altogether new ways of doing things. Now, in Scala, it is particularly important with patterns because there are so many ways of doing things. So it makes it very easy to get stuck in step 3 and step 4. So constantly revisiting the ways you're doing things. You're always kind of questioning, is this really the best way to do it? And as you learn more, you come up with more ways that you can do something, and it's very easy to then get stuck in constantly adopting those new patterns. So Scala is an incredibly flexible language. It is part OO, part FP, and you can mix and match these things in many ways. There are many different idioms. And this flexibility of the language is something that comes with a significant price. And that, again, is the number of degrees of freedom that you have as a developer. It's a big plus, it's a big advantage, but it can also be very challenging as you start scaling out a larger engineering organization. So in Scala-Land, there are very few frameworks. And I think that, there are a few frameworks, and instead everyone wants to talk about toolkits. And I don't think that frameworks and the toolkits are somewhat, is either or. Toolkits, to me, are building blocks for building frameworks. You take toolkits and you put them together and you build a framework on how you actually apply them. But I think there are two reasons why frameworks are so much less common in the Scala community than they are in a lot of other communities. I think one is that the maturity cycle of Scala, I think, is a little bit longer than a lot of other languages because of this flexibility. The community takes more time of coming up with what the idiomatic, opinionated ways of doing things are because the solution space is really, really big. The other thing, though, I think is a factor in more opinionated frameworks is that there are a lot of people that are afraid about actually having opinions or drawing a line and saying this is the way that we should do things to be constrictive because there's still so much more to explore. And it's a pretty we have some very strong opinions in the community, and they're typically on one or the other extreme, and then people in the middle don't really voice their opinions so much. But anyway, you have to construct frameworks in Scala because there are no frameworks ready for you. And it's it's a little bit funny because if you are a Java shop and you speak to another Java developer, and that Java developer asks you, so what frameworks are you using for building X? And you say, well, we didn't really like any of the frameworks that are out there, so we decided to roll our own. And that other developer then will probably just roll their eyes and think that you're full of something, because that's considered to be an anti-pattern in most languages, that you don't roll your own frameworks every time. But in Scala-Land, you actually have to. So I want to talk about a few things that I think are worth considering as you are developing the frameworks that you need for your organization. So the first, and it's an important one, and that's that FP, Functional Programming Mastery, is not required to master Scala. And I put FP in quotes here because although functional programming in its essence is very well defined, what we mean by FP is different depending on who you ask. I think that it's very important to recognize, especially if you're a company that just started adopting Scala, that you realize that Scala is not Java, it's not a better Java. But it's also, as we explore the capabilities and the possibilities in the language, it's also important to realize that Scala is not Haskell. You can do a lot of things that you can do a lot of very advanced things in Scala, but it doesn't necessarily lend itself well to that. So a lot of people in the community, especially those that have recently joined or are looking at Scala, they can see there can be this expectation that you have to be a category theory expert in order for you to be productive as a developer, and that's absolutely not true. And that leads me to the next point, that there are so many possibilities in Scala, and those possibilities, they can be intimidating to some. I know that Kelly has been talking about the jargon in the Scala community that can be, it's precise, but sometimes it might not be necessary. And some developers feel intimidated by this. You shouldn't be. You shouldn't be afraid of learning new things, but you also shouldn't feel like you have to learn all these things in order for you to be productive with it. And I think in Scala, there are so many things that are possible, but it doesn't necessarily make it right to leverage it. So again, when formalizing patterns and agreeing on how you're going to use Scala, don't be intimidated or seduced by all the capabilities. I think that deciding up front on exactly how you're going to, I have a hip chat going on here, let me just figuring out exactly how you're going to apply Scala up front is impossible, especially if you're a company that is just kind of getting started with the language. But I do think that it's important to fairly early on try to get an idea on especially where on the OOFP scale that you want to be. If you are just adopting it, your perspective on what the right level of that will change over time. But pick somewhere on the balance. Decide if you're going to go deep on FB and if you're willing to invest the time that is required to do that, or if you're okay, or if you want to go in light and use it as a slightly better Java, that's fine as well. But try to make that decision fairly early, and then even if you do revisit it later, try to do that with a little bit of rigor. So tools and toolkits are very important when you build a framework. However, tools and toolkits are means to an end. They're not the end in itself. At Tapad, we try to encourage all of our developers to explore the new technologies that are out there, to understand what the different toolkits can provide to us. So we have eager awareness or early awareness of things, but we also try to be very careful when we adopt toolkits and patterns, because we want to really understand what the trade-offs between, or what the tools actually provide to you and what they take away from you. And because Scala allows us to provide very elegant solutions to some pretty hard problems, there are a lot of very good toolkits in Scala-Land that are really tempting to use, but they might not always be right for you. And an example of that is actually the actor model. So Akka is much more than actors now, but back when we started in 2011, then actors was kind of the Akka actors was the primary part of Akka. And if you look at the Akka website, then from just now, you see that Akka is a toolkit and runtime for building highly concurrent, distributed, and resilient message-driven applications on the JVM. Akka is great, and Akka actors are great, especially if you're building highly concurrent, distributed, and resilient messaging applications on the JVM. However, a lot of companies actually don't do that. They don't need this. And I've seen too many examples of where there are these tutorials on how you use actors, and what too many people I've seen, they create these tutorials where you implement a regular business facade, if you want to go back to like Java design patterns, and they implement that as an actor. And what you end up then is basically a service that has the signature of NA to unit. And that's not very, very expressive. That being said, there are lots of problems that lend themselves very well to Akka, but adopting it for the sake of just adopting it, don't feel like you have to apply everything and you have to use Akka just because it's a really great technology. It is, but you really need to think about what it can do for you and know what it is and what it isn't. And 6 years ago, at the Northeast Scala Symposium in Boston or Philadelphia, I actually did a talk on Akka, where I was preaching everything about the actor model, how well it worked for us. And looking back at what we did back then, I do think that we actually had some problems that were very well, had good fit with Akka, but also clear that we had over-leveraging Akka and was using actors for all kinds of problems that it probably wasn't appropriate for. Reactive, similar. Like if you're going into Scala, then you hear that reactive is something that you have to do. Now, reactive is much more than just asynchronous versus synchronous, but that is kind of one of the core differences between reactive and non-reactive. And similar to actors, you need to think about what are you actually gaining from this. So it is not a free lunch. Building a reactive application comes with a lot of caveats. One, the most obvious one, is just kind of the cognitive overhead of having to think or write with futures. Now, Scala expresses asynchronous computation, asynchronous AO. Like you have APIs that make it very, very easy to work with compared to a lot of other languages, but it still comes with some overhead, and you have to think about your applications in a different way. There are also a lot of very sharp edges with reactive applications. So who knows what back pressure is? And who thinks managing back pressure is easy? Right, so everyone knows what it is. 6 years ago, we didn't even think about back pressure because we hadn't really learned enough about reactive to understand what the sharp corners are. And things like back pressure are actually really, really tricky to deal with. And it's not really until the Reactive Streams SPI has come out that you can actually do proper back pressure management throughout an entire application. There's also this expectation that just because your application is reactive, it will perform much better. And whether that's response time or scalability, different definitions of performance, but your application will not be automatically faster just because you're using reactive. In fact, it will be slower, but it might be more scalable. But there are also gotchas, performance gotchas, when it comes to the program model in itself. And again, this is about educating developers and so on. But we started mapping over futures like they were any other kind of monad. And if you do that, you just assume, because it looks the same, that you're not going to have any performance overhead. But for those that actually have done a lot of work with futures, you know what an incredibly bad idea it is to treat the future as any other kind of container that you can map over. So lots of performance issues. There's also this assumption that you cannot make a blocking or synchronous application scale. Also not the case. We have some of our systems, the ones that are doing, let's say, like 1 million requests per second. Those systems are not just one node, obviously, but some of those systems are actually mainly blocking. But we also have reactive applications that also perform well. But it's not a given automatic benefit. You have a lot of compatibility issues. Again, this is something that were more problematic a few years ago, but we, working with early stages of reactive applications, we had to deal with the mapping between Twitter futures, Scala futures, and Scala Z futures, and so on. So compatibility issues there. And then there's also the elephant in the room, which is that most libraries like JDBC drivers and most Java drivers are still blocking. And if you try to mix and match non-blocking with blocking, then you're very likely to end up getting the worst of both worlds. So if you go reactive, then you have to go full stack reactive. And I think now the ecosystem has gotten to a place where this is actually much easier to do than it was 3 years ago. But don't go half in. You have to commit to it fully if you're going to do that properly. So one of the things that drew me to Scala in the first place, I mentioned in the introduction, was the expressiveness and the terseness of the language. And after several years of writing Scala every day, I found myself almost obsessing about terseness. Like always looking at, are there other better ways to express this thing, something that is more elegant than what it was before. And implicit conversions obviously is part of what makes it easy to write very succinct DSLs and so on. This on the board, on the slide here, is a very, very simple example. Obviously, it's probably one of the better uses maybe of implicit conversions, but like the essence is that when you obsess about terseness, like 1 second versus finite iteration seconds 1, sure, it's fewer characters, but the clarity of what's going on there is actually more. The expression of that this is a finite iteration rather than an interval, for instance, is something that is much clearer. I would probably keep a DSL for expressing time, that's fine. But it comes with other issues like if you use import collisions, what do you know? If you look at an API, you see something that's really elegant DSL and you don't know how to import it or you don't know how to use it because the code didn't include the proper imports in the code snippet. Or it also makes it very hard for you to look at, if you're exploring a new API that uses a lot of implicit conversions, it makes it very hard to see what's actually going on. So I think that using implicit conversions can still be a good thing in many cases, but this obsession about terseness and having everything be as small as possible in the code base, I think, is generally not a virtue to pursue. I think everyone these days know, like, it's almost become a cliche about premature abstractions being one of the evils in software engineering, and one-offs obviously also being in that category. In Scala, it's so tempting to write abstractions and keep abstracting things because it feels creative. It feels like you're really putting your tools to work. And I think some discipline when abstracting is really important. So first of all, a pattern is not a pattern until you observed something happening multiple times. So the idea that you are in fact capturing, detecting the right abstraction the first time you see a problem is probably a very bold assessment of your own qualities as a software developer. And I've seen this, and I've done it myself. I've built many one-off abstractions where I think this is going to be awesome, and then I revisit it myself 3 months later. It's like, okay, I never used this again, and I don't know how I got to this. And you added in some implicit conversions in there as well, and it was really, really messy to follow. And I've seen the teams do this as well, and it's part of the learning and part of the fulfilling part of software engineering is doing things in new ways and coming up with new abstractions. And it should be encouraged to think with abstractions, obviously, because abstractions are a fundamental piece of sound software engineering. But in Scala, it's so easy to do these things that you have to try to encourage people to be a little bit more careful. Obviously, having one-offs in application code in your application repositories is not the end of the world. But what is more problematic is when they make them themselves into the standard libraries or the framework that you're working with, because that one-off abstraction is something that if it's used twice, then you're typically stuck with it forever since then. So, like, some more discipline than maybe usual is required. Reinventing things in Scala is another thing that I've enjoyed a lot myself as well. An example, we use Unfiltered as our toolkit for building a lot of our edge services. And unfiltered is independent of the underlying web server. So it can run on any serverless container, it can run on Netty. That was actually, that abstraction was something that I worked with the unfiltered team on back in 2010. However, because of this, the cookie parser in unfiltered couldn't depend on neither the a Jetty version, or one doesn't exist, I believe, in Netty, but maybe it does. But anyways, Doug and the guys there, they re-implemented the RFC, just took the RFC and said, okay, it's easy for me to write a cookie parser in Scala, so let's just do that. So we deployed one of these services back in 2012, and we very quickly saw that it exhibited some weird behavior. One, we saw that every now and then, as in a few times per second, we got requests that had much, much longer response times than we expected. And this is a pure CPU-bound system, and we pinned it down to cookie parsing. The other part was that we found that we saw a lot of exceptions, so errors while parsing cookies. So the implementation of the cookie parser was 100% correct. However, it turns out that not all browsers actually followed the RFC for cookies. Who would have thought? IE5, IE6. Anyways, we took a look at how to solve this, and we dug into the Jetty source code, and so how are they actually handling this? And we found two things. One, that the Jetty cookie parsing code was highly optimized after a decade of performance tuning. The other thing we found was that all of these bugs in the different browsers and the errors in how they're actually producing cookie headers, they had workarounds for all of those things in there. So it's an example of where the temptation of doing this in Scala was big, but what you're missing out on is the maturity of the Java-Land project. So I think that Dispatch is another example. It's actually the same community of developers. Dispatch 1.0, which gained some notoriety back in 2010 because of its use of symbolic operators, but that was a very deep, fundamental Scala implementation of an HTTP client. Scala Reboot, which was developed also by the same guys a few years later, was just a thin wrapper around the Ning async HTTP client. And I think that is probably the right approach. But it doesn't only apply to libraries, although we should borrow from the JVM community when necessary, or as much as possible, actually. But it's also about development patterns. So I used to be I used to do EJBs back in the day. I loved Spring when it came along, bought into dependency injection, and so on. And then when I started developing in Scala, we were looking at, okay, how are we actually going to bootstrap our applications? And at the time, there were really just two patterns there. It was static singletons using objects, and then you had something called the cake pattern, which was kind of, everyone knew inherently that static singletons was an anti-pattern, and that the cake pattern maybe was a little bit better. But honestly, back in 2011, we didn't really understand. I couldn't see the benefits of cake, so we opted not to do that, but we went for the static singletons. In Play, the earlier versions of Play, you actually did not have any choice because all of your controllers were actual objects. Anyway, fast forward 5 years, and Play now supports Juice and other dependency injection providers. And we actually very recently did a refactor because we were upgrading Play and we had to use dependency injection. What we found was that what took the most amount of time in our code base was actually untangling some of the circular dependencies and other bad things in our code base that had broken a lot of the sound software engineering patterns because we hadn't been using a framework like dependency injection that enforced certain rules on our code base. So I think there is a lot for, we shouldn't take everything that comes out of the Java community as the only way to do things, but I think that we as a community have a tendency to also reject everything just because it's Java. So there was some things about what to think about when evolving the patterns and building a framework. And the question is, okay, so when should you start formalizing a framework? There's obviously no easy answer to that. What I do think is that it has to evolve over time. You cannot assume that you're going to just start building a framework one day, and then when you're done with the framework, then you can start getting to your actual work. So you need to allow for evolution to happen over time. What I think is important is that if you go back to this process that I talked about earlier, where you get work done and then you continuously, like every now and then, you revisit your assumptions and find new ways that you can do things better. I think that when you are in step 5 and you're promoting that into that pattern, the new way of doing something into your framework, then you should really invest the time in then going back and changing the old ways that things have been done throughout your code base. This is not something that we've been doing particularly well, but it's something that I wish we had done more of. Because it's like a certain pushback from yourself. If you're seeing that, hey, I found this better way of doing something, but you're not willing to invest the time to go back and change the things that you had already, then maybe it's actually not worth it. At Tapad and at a couple of other companies that I've been advising, I've seen that, especially in Java shops where they want to adopt Scala, they have a Java team, and they might have 1 or 2 Scala developers or people that are interested in Scala, maybe have a little bit of experience with it, and the tech manager, whoever, tells them, hey, yes, we want to try Scala, it looks great. Can you go and build a prototype or a basic framework for us, for the developers to start learning? And if you have like any developer that has been working with Scala, probably in particular, for like 3-4 years, and they get this task, and it's like, yes, finally going to do everything that I always wanted to do with Scala. And they go in on the deep end, and they push the boundaries on the things that they're comfortable, and they go a little bit further. This typically ends up in a situation where you're either alienating the other developers, the learning curve to get to where they are is going to be really significant, and you have to really invest time in that. Or what I've also seen a few times is that that developer or the developers, they really do push beyond where they really should be, and they end up with something that is very hard to maintain for anyone but those guys. So having a small, very small team or one person like do the initial groundwork for the framework is probably not a good idea. Once you've established, you've gotten to a point where the pace of iteration on your frameworks and the way that you do things start to slow down. You should really start letting the tools, including the language, start fading into the background. And I'm going to quote Jeff, who's also here in the audience, who spoke about SPT also at the conference. He says that, well, true mastery of any tool is when I no longer think about it. And I think that's very, very true. And I think actually that the purpose of leveling up an engineering team is to actually get them so comfortable with the tools that the tools no longer matter. What you focus on is actually the higher level design, like what are the problems you're solving and how we're going to solve them. So don't keep obsessing about everything. Like when you found something that your team is comfortable with, you shouldn't stop iterating completely, but it's okay to kind of let that fade back and then just get the actual business problems work. That being said, I think that you should obviously not just leave it and let it go stale. When you bring on new developers onto your teams, you need to train them on the framework, obviously. You need to explain to them what the underlying reasons for the fact that we've ended up with the framework, with these patterns and these idioms and so on, what they are. You need to allow new people that come in with different kinds of experience. We need to allow them to scrutinize the way that you're doing things and coming up with other ways of doing it as well. So again, all this in order for us to keep evolving the frameworks. This is something that is important to do as a team within an organization, and I also hope that we can do that more as a community as well. So I think more frameworks, more opinionated frameworks, more full stack things are actually necessary for Scala to continue to be growing in adoption. I've had a few talks on Scala, and this is like a less technical one. I've done some more technical ones in the past where I've pointed out more specific problems. And a question that I have gotten from the audience sometimes is, well, so do you think that Scala was actually worthwhile? Is it a good thing that you chose Scala 6 years ago? And I think that I overestimated back then how easy it would be to attract people to come work just with Scala. I think it's had some merit in that regard. I think we have a very good development team, and part of that is part of Scala. However, if you asked me 2-3 years ago about what the overall result of using Scala, are we successful because we are using Scala or not, I would probably have said that it was a wash. So on the pro side, we had a lot of fun learning the language and kind of getting our heads wrapped around, our brains wrapped around the tooling and so on. But we also had a lot of headaches because we had to figure out these things that I've been talking about earlier. How are we going to apply this? How can we do this better and then keep iterating on that and doing it too much? The immaturity of the tool chain, the build tools, all these kinds of things. So I think that it was a wash 3 years ago. But if you ask me today, then I think that Scala is a wonderful language. It is something that I know that all of our developers enjoy learning, and once they learn it, they enjoy being productive with it. So I would choose Scala again in a heartbeat, and I know that almost all of our developers, if the new problem that they're seeing, a new thing that we're going to build, they are going to choose Scala. That would be their language of choice. So I'm very happy with the decision, although it was a little bit of a gamble back then. All right, so some key takeaways. Number one, you don't have to be an FP master, however you define that, in order to be a master of Scala. As you're evolving your patterns and your frameworks, try not to be intimidated by jargon or intimidated by learning new things that seem difficult, at least at face value. But also don't be seduced by the capabilities and try to leverage everything that's in there, because that's going to be challenging for everyone. Expect your mindset, though, to evolve over time. The same thing as in any other language, you're going to learn new things all the time, and you revisit something you did 6 months ago, you're going to think, what the heck was I doing? In Scala, this will be even more so than in a lot of other languages. But then lastly, you should really allow eventually the tools to fade into the background as your proficiency increases, and stop worrying too much about the tool. All right. Questions?
Hi, thank you for a nice talk. I have a question. How do you enforce frameworks technically in your organization? Because these developers, they're really hard to tame.
Sorry, I missed the question?
How do you enforce frameworks and this way of working in your teams?
Yeah.
For in Scala, you can do the same thing and both of them are right.
Yeah.
Sometimes I'm seeing coding that in the same class, two styles of coding is being used by the same developer.
Yeah. So there are a couple of answers to that, two parts of it. So one is that I think in a smaller group where you don't have a lot of existing code and you approach a problem for the first time, then you're going to have a lot of disagreements on what the right way to do something is. As your code base increases and your team size increases, then a lot of these things just happen to go away after a while. So it's kind of also part of this, the letting the tools fade into the background. I think a lot of our developers, it's not like they're not curious to learn new things anymore. It's just that to them, they've been through these debates about how to do X so many times that we decided on one thing, and now we just go with that. They see that, yes, there are many different solutions to this. So that's more on the more senior level. On the more junior level, when you have people coming in, they probably aren't that opinionated about it yet, and that's kind of where you need to do some training, and they just kind of assimilate that. Some of it is also done in code, of course, in the libraries. But when it comes to that, like, are we going to use eithers or exceptions, for instance, right? We don't really have that debate anymore because we just do it one way.
What we do is we use Git, and you can't commit to the dev branch, but you can make a new branch. And then if you want to commit it to the dev branch, you have to let it be, you have to pass it to other developers.
Yeah.
And then you have 4 eyes or 6 eyes or 8 eye principle.
Yeah.
So you can discuss.
Yeah, so for code reviews, for enforcing non-codified patterns, that's definitely, like, there's some peer pressure on this as well. So so many of the things that I've been talking about today, we don't necessarily do all of these extremely well at Tapad, and on the contrary, a lot of these things are things that I wish we had done more of in the past. But I think that, like, within the different teams, we have slightly different variations. And I talked about, approachability and moving between teams. There's certainly slightly different variations of style between the different teams, and those are typically those patterns are reinforced by code reviews. So, yeah.
Do you think you got better developers in your company because of Scala?
I'm a little careful, so that's why I'm answering to this. But
I'm also thinking about hiring. I would say it might be hard to find Scala developers. And like I see that being here in Copenhagen, for instance, it's very .NET or Java based. So my thinking is I want to learn Scala. I work for a company that also wants to do a bit of Scala, but we're lacking customers that are ready to jump the wagon.
Yeah.
Mostly because they don't know of it, but also because they're probably thinking it's hard to get developers that can facilitate and lift this.
Yeah. So to answer maybe the first question slightly, at least the first, so I do think that developers that want to learn Scala, they have some traits in terms of curiosity and so on that I think can be good in general. So you have, there are certain advantages to hiring Scala developers, or people that want to learn. When it comes to getting developers that that have experience with Scala, we've actually never really had that as part of our recruiting. Well, there's no requirement when you come work for us that you know anything about Scala at all. In fact, I'd say probably like 80–90% of the developers that we have hired, maybe a little bit more recently because Scala is becoming more and more adopted, but 80–90% of our developers had never written a line of Scala before they came on board. And getting new developers ramped up and be productive in Scala, if you choose not to go too deep out on the FP end, and we're someone in the middle, it's actually something that goes surprisingly quickly. Us being a Scala company has I don't think anyone has had an issue being productive like within weeks. The application domain that we're in and the complexity of systems, that takes much more time than the actual language. Okay, thank you.